Okay, so in this video, we're going to start taking a look at a different type of continuous probability distribution, which is called a normal distribution. We've seen this previously in the course, but we know that a normal distribution is a continuous random variable has a normal distribution if it's symmetric and bell-shaped. And that's what we mean by bell-shaped, is it looks like this. Now, the y values are given by this really, really nasty formula, which we're not going to be working with too much in this course. We're going to be using Microsoft Excel or technology to help us with this. So, for any normal distribution, there are two important parameters. Those are the mean and the standard deviation. Now, I want to think about standard normal distributions. We worked with these when we were doing z-scores. For any standard normal distribution, the mean is 0 and the standard deviation is 1. So if you look at this one up here, the average right here, the mean would be 0. And then as we count up, this would be 1 standard deviation and 2 standard deviations. These are negative because we went down 1 standard deviation and we went down 2 standard deviations. Now, to find areas underneath normal distributions, this is where we're going to use Microsoft Excel. So, when I take a look at my picture I've got here, let me go over to the Excel spreadsheet. And what you're going to do is, these will all be cleared out for you, but remember, these are all the tabs we've used up to this point in this course, and when you click right here, this is your normal distribution tab. It's broken into two situations. Left or right corresponds to if you have a distribution that's shaded to the left or to the right. If it's shaded in between, you're going to use this distribution down here. So when I take a look, this would actually be shaded to the left. So it says find the area underneath the following standard normal distribution. One thing we need is you need to know what this value is right here. So I'm going to tell you right now, it's going to be 1.24. So let's say that z value, again, that corresponds to, let's say it's a z-score of 1.24. And what we want to know is we want to know what is this area shaded to the left. So obviously you can see that we're going to use the left portion of the Excel distribution. So if we're using the left portion, let's take a look at the Excel spreadsheet and see what it's asking us. When I click on left, or when I'm at left or right, it wants the mean, it wants the standard deviation, and then it wants the x value. What that x value is going to be what the upper or lower limit. In this case, it's going to be the 1.24 right here. So I'm going to put my mean of 0 because it's the standard normal distribution, the standard deviation of 1, and then this x value is going to be 1.24. And now I need to decide which one of these two is my graph depicting. Well, let's take a look. We were finding the probability that x is what? That x is less than or greater than 1.24. We can see that this is shaded to the left, so we are finding the probability that x is less than 1.24. So I'm going to go over to the spreadsheet and we're going to read off that value. That's that value right here. We'll round this 4 decimal places, so 0.8925. Or, if we were going to look at this as the percentages, it'd be 89.25%. All right, so let's take a look at another one. So we can see here that it actually, this time it should and it will. It gives us this limit. This z value is 0.26. So this time we are, again, this one actually is shaded. This time it's shaded to the right. Now, what does that mean that it's shaded to the right? We're finding the probability is that x is what? Greater than 0.26 or less than 0.26? We are finding the probability that x is greater than 0.26. Just a little hint here. I like to think of this kind of like an arrow. It's pointing this way because we are shading it to the right. So I'm going to use the Excel spreadsheet to find this. We're going to enter in our mean of 0. We're going to enter our standard deviation of 1. And then this time our our lower bound, we call it a lower bound because it's where it starts, is 0.26. And then I hit enter, and I just need to know which one am I looking for. Am I looking for this one, or am I looking for this one? This is where I look at what I define. X is greater than 0.26. X is greater than 0.26. That's 0.3974. Or again, 39.74%. All right, last one we're going to take a look at. This time we can see that this shading starts at 2.17 and it ends at negative 2.17. We got to be careful. These are negatives. So negative 2.17 and it ends at 0.72. We can see that this is in between. So we are finding the probability or the area in between two values. So when I take a look over at my in-between portion of the normal distribution tab, we can see they ask for A and B, which are going to correspond to our upper and lower bounds, then a mean and a standard deviation. So let's write out what those would be. What would our A value be? Well, that would be where the shading starts, which would be negative 2.17. B would be where it ends, which is 0.72. Then I also need to enter my mean and standard deviation, and since we're in the standard normal distribution, we know the mean is 0 and the standard deviation is 1. So I'm going to enter those values into the Excel spreadsheet. So negative 2.17 all the way up to 0.72 with a mean of 0 and a standard deviation of 1. And it tells us that that's, let's round that 4 decimals again, 0.7492. So how do we write that in terms of a compound inequality? Well, it starts at negative 2.17. I'm going to put the x in the middle. I didn't have enough room to do this. I write really big. So 0.72 here. And then remember, we open the inequalities towards the right. I know that this has or equal to symbols. That's a typo, so it should just be less than and then less than there. But the probability is 0.7492. All right, let's take a look at going the opposite direction. Now it says for the following problem, shade the situation for the proper distribution, then find the area under the distribution. This is a standard normal distribution. Whenever I see those words standard normal distribution, that tells me right away that my mean is 0 and my standard deviation is 1. What does this say? I am finding the probability that x is, what does that symbol mean? That means greater than negative 2.1. So negative 2.1 would be right here just to the left of negative 2. And then we're shading for all the values greater than. So that would be all this stuff right here. So remember that this is a number that should be pretty close to the total area underneath this distribution is going to be 1 or 100%, right? So I better get a number close to 1 because I've shaded this entire value. So when I go over here, it's important to be able to shade the distribution. We know we're looking for the right. So again, our mean is 0. Our standard deviation is 1, but we need to change this to negative 2.1. And we're looking for the probability that x is greater than, so 0.98214. So about 98% of that graph is shaded. That's what we thought. It should be a number pretty close to 1. The next one says the probability that x is less than 1.654. Remember that this symbol means less than. I look at it like an arrow. It's going that way, so that's the way I'm going to shade. 1.654 is something like right here. Less than is going to be all of this stuff on this side. Again, this is going to be a pretty big percentage. I'm shading a good deal of this graph. So I am going to go to my normal distribution. We're still picking the left. The mean is 0. The standard deviation is 1. And then 1.654. And we're doing less than this time, so 0.9509. About 95% shaded. Not quite as much as this one up here, but pretty close. All right, the last one. It says, find the probability that x is, when I see this compound inequality, we're thinking between. So between negative 1 and 1, negative 1 is right here, positive 1 is right here. We're going in between, so we're going to shade the stuff in the middle. Now, I'm going to use the in-between tab, correct? So the lower limit, the A value is -1. The upper limit, the positive value is +1. Mean of 0, standard deviation of 1, 0.6827. Now, or 68.27%. It says, how does part C relate to what we learned previously about the empirical rule? One thing we know about the empirical rule, remember that we said that if a distribution is normally distributed, that if within one standard deviation, it's 68% of the data. I think we did this in chapter 3 of this course, if you take a look at that. Well, we've just used the normal distribution calculator to kind of verify this, because we calculated the area between -1 and 1, and we found that that was just a little bit over, but pretty close to 68%. So how does this relate? It goes back to chapter 2, which is what we talked about. Within one standard deviation, it's 68% of the data.